All right. The final lesson of this graphical analysis unit is on quadratic systems of equations. So quadratic systems, basically, they involve a quadratic equation, right, or quadratic function. All right, so if you recall back from a couple lessons ago, quadratic, just right here. So the quadratic graphs were parabolas, and a linear linear equation is a line. Okay, so the first type we're going to look at here is what they call a linear quadratic system. All right, so in other words, one graph will give you a line, one graph will give you a parabola, and then we're going to basically solve it by graphing. All right, and then we're going to check then we're going to check your solution algebraically. All right, so just give me 1 second here. Type in there. We're good. All right, so then check your solution algebraically. All right, so yeah, so linear quadratic systems, they have one graph is going to be a line, the other graph will be a parabola, and just like the previous lesson, the solution is going to be where the line intersects the parabola. All right, so let's start off with the first one here. I'm going to fire up the old Desmos. So got it open over here on this browser. Yeah, so let's just go into it. All right, so I'm going to see if this works. I'm going to copy paste it into Desmos. Paste. I think I can just use my keyboard. Yeah, there it is. Perfect. All right, so there's my parabola. Copy this one. Not. All right. Here we go. All right, so there's the two graphs, or the graphs of the two equations or functions. And again, the first one here is a parabola. The second one here is a line. All right, and you can see as a result, we get this graph. All right, so let me just a little bit clearer. And so the solution is where the line crosses the parabola. Now, in this case, you can see that there are actually 2 points here. All right, so we have two solutions. Okay. So the solutions are -4, -11, and -0.5, -0.5. All right, so -0.5, -0.5. Okay, so it is possible to have two solutions, right, to a linear and a quadratic system. All right, so the second part here asks us to check your solution algebraically. All right, so yeah, so we're going to check both of these. And so just like the previous lesson, in order to check, basically what we're going to do is we want to plug these in for x and y and make sure that the left side equals the right for both of them. So first solution I'm going to check is the -4, -11. All right, so let's just see what happens here. The left side should match the right. So when I sub it into the first equation, -11 is my y value. The -11 equals -2 times x squared, so -4 squared, minus 6 times -4 minus 3. Okay. So let's see here. -11 equals -2 times. -4 squared is 16. -6 times -4 is positive 24. And we have minus 3. All right, so -11 equals -2 times 16 is -32 plus 24 minus 3. All right, so let's add this together. So negative 32 plus 24 is negative 8. Negative 8 minus 3 is negative 11. Cool. So we got that one to match up. And we also need to check the second equation here. So the line y equals 3x plus 1. All right, so again, for y, and that was my x and y. So for y, I'm going to plug in negative 11. And then for the x, I'm going to sub in negative 4. So that's how the second one should look like. So negative 11 equals negative 12 plus 1. Negative 11 equals negative 11. And we're good. Perfect. All right, so the first one here is a solution, and we checked it. Now the second solution we also need to check. All right, so I'm going to check negative 0.5, negative 0.5. So we're also going to check the second solution, negative 0.5, negative 0.5. All right, so if I sub it into the first equation here, y equals negative 2x squared minus 6x minus 3. I just want to make sure I got that right. Yep. All right, so let's just plug that in. So negative 0.5 equals negative 2 times negative 0.5 squared minus 6 times negative 0.5 minus 3. All right, so let's see what we get. Negative 2. All right, so negative 0.5 squared is positive 0.25. Negative 6 times negative 0.5 is positive 3. Minus 3. Okay, so negative 0.5 equals negative 0.5. And actually, you see here that the plus 3 and the minus 3, you just cancel each other off. So yeah, negative 0.5 equals negative 0.5. So that one works for the first equation. We also need to check it for the line. So the line equation was y equals 3x plus 1. All right, so when you plug in negative 0.5 for y, and we're going to plug in negative 0.5 for x, and we work this out, negative 0.5 equals negative 1.5 plus 1. Negative 0.5 equals negative 0.5, right? And it works. Perfect. So yeah, so when we found the two solutions through Desmos, we still need to plug them in for x and y into each one of these and make sure the left side matches the right. And it did work out. Okay, so that's how you check your solutions. Cool. All right, so the next one here is a application problem or a word problem. Now, actually, before I do that, I'm going to go back and just kind of show you some of this. What are the actual possibilities for the number of solutions? Okay, so number of solutions. Just going to squeeze that in here. All right, so obviously, it is possible for the possibilities is we can have two solutions, as was the case in this example, right? So if I have a parabola, you can open up, open down, doesn't matter. But I can also draw a line, and if it crosses the parabola twice, you can have two solutions, right? What is another possibility? Well, another possibility is to actually have no solution. Okay? So that occurs when you have like a parabola like this, but let's say the line just misses the parabola entirely. All right. So over here on the Desmos here, I'm actually going to create one where that's the case. So I'm just going to move this line. I'm just going to move it up a lot. So let's see what happens. I'm going to change that 1 to a 10. All right. So this works. All right. So you can see here that the parabola itself does not cross the line. So this would be an example of a system with no solution. All right, so yeah, so the solution itself, or the line never crosses the parabola, so therefore there is no solution. Okay. Now there's actually a third possibility, which I think hopefully can squeeze onto that page. Yeah. Okay, and so the third possibility is when we actually have one solution. All right, so this occurs when, again, I'm just going to draw a random parabola. When the parabola itself and the line will just touch the parabola, but will not cross it. So it just touches that one point. Now this line here has a special word to it, or special name to it. It's called a tangent. So a tangent is a line that touches, but does not cross, right, the parabola. Now, so this is also a possibility to have just one solution. Okay, so am I going to attempt to create one here? Yeah, let's see if I can here. I'm just going to change the slope actually of this line to just a little bit flatter. So just call that X. And yeah, so let's just shift this down. Just change that to +4, see what happens now. All right, so you can see here it's going to cross twice. So let's see, +3 point. I'm just kind of, yeah, I'm being a little bit finicky here. 2. No, I don't think this. Okay. Yeah, we got to be. See how it just kind of touches, but I don't actually think it touches. It just misses by a little bit. So yeah, so we're basically like maybe splitting atoms here, but 1, 9, 1, 8, 7. See what I'm doing, guys? I'm just making it, just dropping it down lower and lower until it maybe hits. Anyways, I'm just kind of 3, 2. All right, so yeah, I didn't quite get there, but I believe that this one here, yeah, it actually touches twice, but you kind of get the idea. All right, I could possibly, if I get really, really specific, it'll just touch this curve at one point. Yeah, so 3 completely misses. So let's say 2, 5 maybe. Yeah, it touches root. So yeah, so this is tangent. We just touch it at one spot, perhaps. I think in this case, yeah, it touches it too, but very close. So anyways, you can see that there is a possibility where it just touches at one point. So that is the third possibility, is when you have one solution. Cool. All right, so let's, yeah, so one solution is when it touches. All right, so let's go on to the next example here. So example 2, the equations below model the number of cell phones sold in hundreds and days after the phones were introduced. Okay, so X is the number of days it was introduced. Y is the number of phones sold on that day. All right. So the first question here is, on what day or days did the company sell the same number of each phone? All right. So what I'm going to do here is just basically graph these 2 lines. Right? So I'm going to a little shortcut method here. And copy and paste it on. So first line I'm going to graph here is y equals 7x minus 30, and the second one here is the parabola. All right, so it looks like it's off the screen here. All right, so what we're gonna have to do with this graph here is kind of play around with it until we can see where it actually touches. or where the line crosses the parabola. All right, so right now it probably looks like two lines, right? So let's just zoom out a bit. All right, so you can see that the green one here is the parabola, and the red is the line here. Okay, so it's going to cross somewhere here. The beauty about Desmos is I can just kind of click through it, and it'll automatically give me that point of intersection. So if I zoom in to that point, yeah, so you can see that this is where the two lines cross. All right, so on the 20th day, both models sold 110 times 100. So what's that? 11,000 phones. Right? Now it's going to cross somewhere else. Right? So with this thing, it's going to cross somewhere else. Now the thing about that though is if I scroll down, you can see that yes, it's going to cross, but it's going to cross down here in the negative, right? So -10 and -100. But in the context of application problems, it doesn't make sense for it to be like -10 days and selling negative 10,000 phones, right? So it all starts right here, right, at 0, 0, positive. So when it comes to applications here, we're just kind of looking at this part of the graph where it's in the positive axis, right? Because we don't have negative time and we won't have negative numbers sold. All right, so these two graph parabolas, the parabola and the line will cross right here. So that is at 2110. So I'm going to write that down as the point of intersection. Okay. So the point of intersection okay, so point of intersection. So another intersection is at 2110. All right, now the key thing here is, on what days did the company sell phones? So our X is the number of days after it's introduced. So it's on the 20th day. They actually sold the same number of phones, and how many phones of each type were sold. All right, so the same number of phones was 110 for your Y. But when we read the question, the Y is in hundreds. So I need to multiply that by 100. So that will give me 11,000. So on the 20th day, the company sells the same number of phones, right? Which is 11,000 phones, but Model A, Model B. Right? And that's how we interpret this, point of intersection. Cool. All right, now the last example here. This is actually, I guess, the other type of quadratic system is when we have a quadratic system. So quadratic system is when we have basically two parabolas. So what we're going to do here is, we're going to just graph these two parabolas, and we'll see where they cross. All right, sound good? All right, so let's just copy and paste that on here. Copy. Let's just close these up here. All right, so I'll paste it with my keyboard, Control V. And let's copy and paste this one as well. Paste. All right, so obviously I'm going to have to fix this. So I'm going to hit the home button here. It just goes back to the default. And actually, yes, the default here looks like it looked like there. Looked like it was, it does a pretty good job of showing the two parabolas. All right. That being said, though, I'm just going to change the color of these. Let's go with red. Red and green. All right. Cool. All right. So here's the red parabola, green parabola. You can see that it crosses at two places. So you got to be very careful, actually. If I click here, if you look very careful, this is actually the vertex. So I want the other point, which is that one, which is this one here. Okay, so that's where it crosses as well down here. Okay, so these are my two solutions. All right, now, what you see here is that they're not really the prettiest of numbers, right? They go to 3 decimal places, which is fine. But anyway, so I'm going to write those down as the solutions. All right, so our solutions. All right, so as it turns out, our solutions are the first point there, 1.818, comma 11.149. And my other solution is going to be negative 3.484, negative 13.594. Okay, so those are my two solutions. And what we also want to do here is check our answers algebraically. All right, so what that means is, yeah, process still the same, and you might find this long and boring, but I'm going to do this as quickly as possible. It's basically I'm going to plug in these points here for x and y and make sure that the left side matches the right for both. All right, so let's do that. Actually, I probably need a calculator. Let's open up the calculator. This a little bigger. All right, so first one here, let's check this 1 point. You know what? I'm gonna round it. I know what ends up happening now is like if I round it, perhaps the number is going to be off just slightly, but as long as they're close, that's fine. So I'm just going to go 1.8 and 11.1. All right, so let's check that one. So when I plug it into the, so we'll call that 1 and 2. So I plug it into the first equation there. I get 11.1 equals 2 times 1.8 squared plus 8 times 1.8 minus 10. All right, so 11.1 equals, all right, 2, see if we can do this all at once. 2 times 1.8 squared, yeah, plus 8 times, no, I already messed up. Okay, try that again. 2 times 1.8 squared plus 8 times, all right, I don't want it. Okay, so it looks like this is what it's calculated. All right, I'm gonna have to break this down into pieces. All right, so 2 times 1.8 squared equals, all right, 6.48 plus, all right, 8 times 1.8 is 14.4 minus 10. All right, so let's just add those up together. So yeah, 14.4 plus 6.48 minus 10. I get 10.88. Oh, that's actually a big difference. All right, you know what? Yeah, I'm gonna go back on this, and I'm gonna go to like the 3 decimal places. All right, so this looks like I think I did the math right, but we're not 100% convinced, right, as a check. So yeah, so please forgive me for wasting the last 2 minutes of your lives. I'm going to have to get a little bit more specific, I believe. So let's just erase this. All right, so in red here, yes, I'm going to check. I'm not going to round it. Lesson learned. All right, it's going to throw your answers off by a little bit. So let's go to 3 decimal. We should be pretty safe with 3 decimal places. Okay, so that's the first point I'm going to plug in. 1.1, I'm sorry, 1.818, 11.149. Plug that in for x and y. All right, into the first one here. So 11.149 equals 2 times 1.818 squared plus 8 times 1.818 minus 10. All right, so 11.149 equals. All right, let's see what we get here. So 2 times 1.818 squared. Let's go with equals. Okay, let's see if I can do all this once. Now I'm going to add 8 times 1.818 minus 10. Yeah. Okay, so I'm going to have to break this down in pieces. This calculator is a little, won't allow me to do it all at once. All right, so anyways, 2 times 1.818 squared equals. All right, so we have 6.610. Actually, let's just go through this one, please. Plus, all right, so 8 times 1.818 equals. All right, so this one's 14.544 minus 10. Okay. All right, so let's add up that side here. So 14.544 plus 6.610 minus 10 equals. All right, so 11.1. Yeah, it's a little better. 1.54. We can just say that is close enough. All right, so yeah, just a little bit rounding. The reason it's rounded off is because we did rounding when we're checking. And I imagine that these points actually are rounded off with just a little bit. All right, now we need to check it with we need to check it with the second one too. All right, so I'm going to plug in 11.149 for the y. And from the second equation, I have negative x squared. So x in this case is 1.818 squared plus 3 times 1.818 plus 9. All right, so let's work this one out. 11.149 equals. All right, so 1.818 squared. Oops. 1.818 squared. And that's negative. So negative 3.305 plus. All right. 3 times 1.818. 5.454 plus 9. All right, so let's see what we get here when we combine the terms on the right side. So I got 5.454 negative 3 points, so minus 3.305 plus 9 equals, and we actually do get the exact same number here. So 11.149. Okay, so that one works there. All right, so that means that this first one here, yes, is a solution. We also need to check the other point that we got. So the other point we got here was this one here. So negative 3.484 and negative 13.594. All right, so let's check that. So so if I plug that into the first parabola, what I'm going to do is actually just going to use this line here. So that's my x and that's my y, right? So, so my y here is negative 13.594 equals, all right. Okay, so this equation here, so 2x squared. So 2 times x squared. So x here is negative 3.484 squared, all right, plus 8x plus 8 times x Minus 10. All right, so let's see what we get here. All right, so 2 times negative. Now, the thing is, I'm not going to bother putting the negative, punching the negative sign into my calculator because negative times negative is still positive. So this number here squared is the same as positive 3.484 squared. Hopefully that makes sense. Right, because when you multiply 2 negative numbers together, you get a positive. When you multiply 2 positive numbers, you get a positive. So 3.484 squared. So that's going to equal 24.27. Let's round it to 7. All right. All right. So 8 times 3.484 negative equals negative 27.872. And then we have the minus 10. All right, so let's see what we get here. So here I got a negative 27.872 plus 24.277. 277 minus 10. All right, so we get negative 13.595, which we'll say is close enough. Right? It's only off by 1/1000th, which is actually pretty good. All right, and finally we need to sub this one into the second equation here. So y equals negative 13.594 equals. All right, so what's this equation here? This is negative x squared. So negative x, which is negative 3.484 squared plus 3x minus plus 9 plus 3x plus 3x, so plus 3 times x negative 3.484 plus 9. All right, so let's see what we got here. All right, so 3.484 negative, and if I square that, we have positive 12.138. All right, but then again, we have the negative sign out here, so this is going to turn this into negative. Next up, I got 3.484 negative, right? Times 3. All right, so this is negative 10.452, and then plus 9. All right, so let's see what we get here. So we have the negative 4.52 in the calculator, and there I'm going to minus 12.138, then I'm going to add 9. All right, so negative 13.59. All right, which again is pretty close there. So yeah, so when we check it, the left side matches right. So yeah, this is a bit of a painful one here with all the decimal places, but principle's still the same, right? Whenever you get a solution, when you plug it in for x and y into both equations, the left side should match the right. And yes, for this one here, we have 2 solutions. Right? So a quadratic system is when we have 2 parabolas. All right, guys, so that's the final lesson of this unit.